Okay, so now we are going to discuss on hypothesis test, which specifically focus on comparing the means of two related populations. Yeah, we are going to use the pair t-test technique for this. Okay, okay. So just recalling what I discussed before. Yeah. So we discussed and we understood on how the two sample hypothesis test can be categorized into two bins or two groups. The first one is independent populations and the second one is related populations. Yeah. Concerning the related populations, yeah, the population 1 and population 2, uh, this the sample of both population can be the same items or the same category of individuals, yeah, with the same paired ID, yeah, or it could also be the case that these two populations are indeed the similar subject, but they are undergone two different treatments, yeah, with a different measurement time. Yeah, so usually it's before and after treatment. Yeah, so yeah, the related population can be the same items of or individuals. Yeah, or due to different treatment of condition. I've explained it in the previous video, right? Okay, and thus, yeah, because the samples of both populations are related to the same identifier, yeah, either it's matched samples or repeated measures, the emphasis of the hypothesis testing procedure is more into the difference, yeah, the delta between population 1 and population 2, yeah. So if you see, yeah, so in related populations, usually it's paired by similar characteristics ID, yeah, and the hypothesis statement is not inclined to whether the sample one or the population one's mean are the same, is the same with the population's mean in sample two, yeah, or whether the mean in sample one is larger than or smaller than uh, the one in sample two. But yeah, in the related populations context, the emphasis is more into the difference. Yeah, how uh, how does the populations differs before or after the treatment, for example. Yeah. So the emphasis and the hypothesis statement is inclined to this very column. Yeah. So let's move to the uh, an example sample. Yeah, an example sample data set. For example, in a match sample, we try to uh, study how the monthly income of different job functions are different, yeah, in Bandung and Jakarta. Yeah, the main interest is not on how much the income is when somebody's in Jakarta or in Bandung, but more into what is the difference. Yeah, whether Bandung is smaller than Jakarta or Jakarta is bigger than Bandung in terms of the delta or the difference. So here we can see that the value is subtracted, yeah, sample one subtracted by two, then we know the difference. 3 minus 5 equal minus 2. Here, for example, 30 minus 50 equal minus 20, which means that the monthly income in Bandung is minus 20, is 20 millions lower than in Jakarta. And this is for match sample and also for repeated measurements. Yeah, for example, Budi, before he go to Jakarta, before moving to Jakarta, his income is 3 million rupiahs, and then after he uh, moved to Jakarta, the income is 5 million rupiahs. Yeah, then the main interest in related populations hypothesis test is whether I mean, the magnitude of the before and after effects, which is 3 minus 5 minus 2. Yeah, and there Slamet, for example, in Bandung he gained 5 million rupiahs. After moving to Jakarta he gained 8 million rupiahs. Then the difference will be 5 minus 8 equal minus 3. Yeah, the emphasis on the difference of those two different treatments of the same respondents can be seen by the hypothesis statement. Yeah, here the hypothesis statement is related to mu taking the mean as the focus of the parameter. Here we can see that the hypothesis statement is centered on the difference. Yeah, so here hypothesis null, for example, the mu difference between population 1 and 2 equal to null. Yeah, this mu d or mu difference equal to mu1, or the hypothesized mean value of population 1 minus hypothesized value of population 2. And this is also the same for, we can also state it in another versions, but here we can see that the hypothesis statement is focused on the difference, right? Here, mu d larger than 0 or mu d lower than 0. Yeah, so not if we compare it with the case at the independent two sample test for independent populations, then the hypothesis statement will be mu1 equal mu2, or mu1 is larger than mu2, or mu1 is smaller than mu2. Yeah, but here in a related context, the statement is more into the difference. Yeah, that's why we state it like this. Okay, in conducting this two sample tests in the related populations using the pair t-test, yeah, the assumptions is, yeah, the difference value is randomly selected and then follows normal distribution, and and the sample size is large enough if, for example, the distribution is skewed. But I don't want to go to this point. Yeah, I just want to go to the main principle. Okay, in conducting the pair t-test, yeah, for related populations, there are two instruments, yeah, similar like before. Yeah, the first one is the t-table, yeah, in which you can locate the boundary of the region of non-rejections and the region of rejection by defining the degree of freedom and the significance level or the error rate. Yeah, here the first instrument, and the second one, of course, the calculations of the critical value. In the pair t-test case, we use this formula. Yeah, so the critical value calculations is a function of d bar, which is an average value of the difference between the two populations. Yeah, and then the hypothesis mean difference, and then the standard deviations of the difference between two populations, and the number of sample. Yeah, the size, the sample size, the number of respondents that we are analyzing. Yeah, note that in related populations context, related samples context, we use this formula. This is different with the one that we used previously at the independent case. Yeah, this is the formula for the independent case, in which we, you know, the input is the average of population 1, population 2, and so on. Yeah, so we are interested in the characteristic of each populations, but in related we are interested only on the difference. That's why the formula is also different. That's why don't be mistaken. Yeah, don't use this formula for, you know, for assessing the mean difference into related populations. This one is for independent populations. Okay, without further ado, let's just jump into problem set. Yeah, because I think we can learn better how to apply the calculations. Yeah. So we have a problem set example here. So for example, you want to examine, yeah, whether the book prices in physical store are similar. Yeah, whether it's sold in the physical bookstore like your shopping malls, or whether it is sold in online stores like, yeah, like Bukalapak, Tokopedia, Shopee, whatever. Yeah. So here the task is to determine at the level of 0.05 significance whether the book prices at the physical bookstore are different from the prices offered at the major online retailer. Yeah, so we want to compare the prices of goods. Yeah, compare whether the one that is sold at the physical bookstore and the online retailer can be considered as similar or not. Yeah, so we have two population. One is, of course, the physical bookstore, and then the one is from the online store. And then what we do, we pick sample of prices for each. For example, the first book is the multivariate statistics. Yeah, the title of it is multivariate, and then you write down, oh, for the physical bookstore, the price is $179, for example. Yeah. While on online, the price of this book is the same. The price of the similar book is $151. And then you go to the next title, and you write down, or at the physical bookstore, for example, information systems cost $123 in physical bookstore, while on the online store it costs $148. And then you write down the data. Yeah. Okay. In order to determine whether the mean average of prices are different or not in this related populations context, we also apply the same procedure, yes, which is the critical value to hypothesis testing, the 6 steps approach. Yeah, this is only one method, of course. Yeah, but in principle, yeah, it's easy to follow. That's why I share this method to you. The first one, of course, stating the null hypothesis, then alternative hypothesis. The second one is choose the level of significance and the sample size. No? The third one, determine the appropriate test statistics and sampling distribution. The fourth one is determine the critical value, that will divide the region of non-rejections and the regions of rejections, right? And then the fifth one is, organize the data and then compute the value of test statistics. Yeah. And then state the decisions and the managerial conclusion. Okay, without further ado, let's go to the first steps of the method. Yeah, first one is stating the null hypothesis. Yeah, of course, because we want to determine whether the price is similar or not. The null hypothesis in this case is the mean difference between these populations is equal to 0. Yeah, so mu1, value 1 minus value 2 equals to 0. And the alternative, of course, is the antithesis of the null hypothesis, which is mu1 minus mu2 or mu d, yeah, is not equal to 0. Yeah, so the null hypothesis is there is no difference in the mean price between the bookstore and the online retailer, which we can indicate as mu d equal to 0. And then the alternative is, of course, the opposite of it. There is a difference in the mean price between the price in the bookstores and the online retailer. Okay, first step's already done. The second step is choose the level of significance and sample size and the degree of freedom. Sample size, level of significance, and the problem set's already stated 0.05 or 5%. Sample size here, yeah, we pick 1, 2, 3, 4, 5, yeah, 6, 7, 8 until 15. because we are interested only on the difference. That's why the sample size is 15. Yeah, in related, we only count the pair. If the pairing, if only 15 pair, then the sample size will be 15. Note that in the independent case, yeah, we are interested in each of characteristic. Then the n value will be for population there are 15, and then for population 2 there are 15, then 30. But here in the pair context, we only count the pair. That's why the n value equals to 15. Yeah, here it's 15 pair, 15. And the degree of freedom is also calculated based on the pair, yeah, which is n minus 1. Then 15 minus 1 equal 14. Yeah, easy, nah? Easy peasy, chiki chiki. Going to the third step, determine the appropriate test statistics and sampling distributions. Yeah, in the problem set, yeah, assume that the means difference distribution are normal. That's why, because we can see there that we want to compare the difference of these two populations with the same pairing identifier, then it's a related population context. Yeah? That's why we use paired t-test. And the sampling distribution at the problem set already stated that it's normal. Yeah. Since we are interested in evaluating the means of two related, not independent, yeah, then we can use pair t-test, yeah, pair t-test for the difference between two means. And from the problem set, it's already stated that we can assume that means difference distributions are normal. Okay, now we go to the fourth step, yeah, which is okay. The fourth step is determining the critical value that will divide the region of non-rejection and rejections. We understand that the alpha is 0.05, yeah, pretty much. And because the hypothesis statement is equality, yeah, equality, which is mu d equals to 0, then because it's equal, then it's a two-tailed test in which the significance or the error level is divided into two directions, yeah, 0.025 to the left tail and 0.025 to the right tail, right? And in determining the critical value, because we use the pair t-test, we use t-table. And then how to define it? Of course, the degree of freedom is 15 pair minus 1, yeah, then it's 14. Yeah, and then the critical value is 0.025. Yeah, so pretty much, yeah, 14, and we go here, so it's 2.1448. Exactly. Yeah, and then we plug in the number plus 2.1448 at the right side and minus 2.1448 at the left side. Okay, now we'll go to the fifth step, which is determining the test statistic value. Yeah, and then the fifth step is collect sample data, organize the result, compute the value of test statistic. Okay, we have this formula to determine the test statistics. The t-stats is a function of d bar, which is the average value of the difference between two populations, and then the hypothesis size mean difference, which is we hypothesize that mu d equals 0, then mu d will be equal to 0, right? And then also a function of standard deviation of the difference, yeah, population 1 and population, and n is the number of pairing, which is in our case equal to 15. Now let's see how we can calculate the d bar. Yeah, I will go to the average value of difference. It's really easy. So I will go to my Excel sheets here. Just okay. You can see. So here's my Excel sheet. Remember, that we want to to focus on the difference, the difference between the sample 1 and sample 2. Yeah, so price difference equal, yeah, sample 1 minus by the value of sample 2. Yeah, so here 180 minus 150 equals 30. Yeah, 120 minus 140 equals minus 20. Yeah, I will just drag down here. So we will have all the difference value. Yeah, I will just highlight this. Bam. Okay, and then go back here. As you can see, we need, so this one is already we understand already the value of it. We still require the d bar or the average value and then the standard deviation. And then using Excel, then it's really easy. Just equal average, yeah, of all of this price difference value, and then you got 30. Yeah, so in the physical bookstore here, yeah, the average difference value is 13, which means that on average the price of physical bookstore is $13 more than the ones sold in online, with standard deviations of, so here we as the def s, yeah, and then we just drag and drop, bam, yeah, with a standard deviation of 33.14, which is quite large actually. Yeah, okay, now we have already the d bar and the sd value. Then we just plug it in into the formula, right? So I just here, yeah, okay, just, yeah, so we have the d bar, yeah, here, yeah, or the average value. Then we just simply plug it in here. Yeah, this is equal 13, and then the standard deviation we plug here, yeah, equals 13 or 33.14. Yeah, which then, yeah, I will rewrite the formula into here. Yeah, the t stats value after we calculate it is equal 1.5 something. Okay, we finished the 5th step. Now we go further to the 6th step, which is state the statistical decision and managerial conclusions. It's really easy. Yeah, so we have already the critical value. Yeah, we define at the 4th step that the t critical value is between minus 2.1 and plus 2.14, and then the test statistics calculation equals 1.5, which means that it is 1.5 is located around here, right? So it's located inside the region of non-rejections, the region of non-rejection. Thus, yeah, we can state, because the t-stat value is 1 plus 1.5 is located within the region of non-rejections, yeah, so it is inside this. Thus, the null hypothesis that states the mu difference or the mean difference between the online store and the books and the physical store is pretty much similar, cannot be rejected or can be accepted. Yeah. So that's it. Yeah. So here we the conclusion is that the mean difference between the online and the physical is negligible, or it can be considered as similar. Yeah, here actually it's not that surprising, yeah, because as we can see here, yeah, the mean average difference is only $13, and the standard deviation, yeah,